Hello everyone, welcome back to uLearn Education Online channel. In the previous videos, we have seen what is the setup of communication system and also the signal terminology or signal naming in the analog communication course. Now, in today's video, we are going to see what is modulation and what is the necessity of using modulation in analog communication course. As we know that the low frequency signals is having a low energy signal and low power signal and is not travel for longer distances. In order to travel the low frequency signal with less power in longer distances, we are using the technique called modulation. Now, what is modulation and how it is achieved, we are going to see now. Here, the modulation is nothing but the superimposing of a high frequency signal with the message signal, which means the changing of the characteristic parameters of high frequency signal. So here this carrier signal is a high frequency signal and we are changing the parameters of the signal. Now what are the parameters of the signal? One parameter is amplitude, frequency and phase. These three parameters of signal will change according to with the message signal. In this way we are achieving the modulation, and the signal that is resulting from the process of modulation is called modulated signal. So finally, the superimposing of message signal with the carrier signal, we are obtaining a modulated signal. So this is modulation. Now in the next one, we are going to see what is the necessity of modulation. The first parameter that needs the use of modulation in the communication system is the antenna. So here we have to reduce the height of an antenna. Why the height of an antenna should be reduced? If you consider the wired channel, then there exists either a coaxial cable or an optical cable in order to transmit the signal from source to destination. Whereas if you consider a wireless channel, so if you consider a wireless channel, here the transmission is possible only with the help of antenna, which means the messages are transmitted and received with the help of antennas if you consider the wireless channel. So for the proper radiation and the reception of the signal, the height of an antenna should be the quarter wavelength of the frequency. That is, if you consider the height of an antenna as h, then it must be the quarter wavelength of a frequency. Or if you consider in terms of a wavelength, then the h value should be lambda by 4. So we know that the wavelength in terms of frequency. So here the wavelength lambda can be expressed in terms of frequency as c by f, where c is the speed of a light and its value is 3 into 10 power 8 meter per second. Okay, c is the velocity of light and f is the frequency which is measured in terms of h. So finally, the practical antenna height in terms of frequency is given as h is equal to c by 4f. So this is the practical antenna height in terms of frequency. Let us consider the voice signal frequency range. Now, what is the voice signal frequency range? So we know that the voice signal frequency range is 300 Hz to 3.5 kHz. Now, if we want to transmit a signal in this frequency range without modulation, then let us see what is the height of an antenna will looks like. So if I consider that I want to transmit a signal of frequency having 3 kHz, then without modulation, if I consider to transmit the signal, then see what is the height of an antenna will be. So without modulation, then it is the practical antenna height, that is lambda is equal to, we know that lambda in terms of frequency, that is c by f, and in previous we have find the practical antenna height h value is c by 4f. We know c is the velocity of light and its value is 3 into 10 power 8 meter per second, and f is, we are assuming 3 kHz. Now simply substitute that values, then h is equal to 3 into 10 power 8 by 4 into 3 into kilo means 10 cube. So 3 gets cancelled, 10 cube it is 5 times. So 10 power 5 by 4, which is 25k. Okay, which is in terms of meters, then it is 25,000 meters. So in order to transmit the frequency of 3 kHz, we have to construct an antenna height which is 25,000 meters or 25 kilometers. But which is not possible practically. So the height of an antenna should be reduced. Now what is a method that is used in order to reduce the height of an antenna? That is the use of modulation. So here the modulation process increases the frequency of a signal based on the requirement. For suppose, let us consider I want to transmit the same signal. Okay, so this signal is having the frequency f as 3 kHz. So with modulation, I can shift this signal frequency to the higher value. Means with the use of modulation signal, I can shift this 3 kHz frequency to 3 MHz frequency. Then let us see how the height of an antenna value will be. Then it is height is equal to C by 4F. Now simply substitute. C is 3 into 10 power 8 and frequency is 3 mega, that is 3 into 10 power 6. So 3 gets cancelled. So it is 10 square by 4, which is 25 meters. Okay, which means the height of this height of an antenna, that is the 25 meters height of an antenna, should be achieved practically. Therefore, if the frequency increases, the height of an antenna will be reduced. So the modulation is required in order to reduce the height of an antenna when we are considering a wireless medium. And the second parameter that is needed to use the modulation technique in the communication of signals is in order to reduce interference, or we can say that remove the interference of a signal. Now why this interference will appear? So here the interference occurs in the process of transmission of multiple number of signals through a single channel at the same time. Okay, so let us consider the frequency range of an audio signal, that is ranges from 20 Hz to 20 kHz. So we know that in the radio broadcasting, several radio stations will be present. If there is no modulation, then multiple number of signals which is having an audio signal frequency range, that is 20 Hz to 20 kHz, will simply transmit through the single channel at the same time. Due to this transmission over having the same range, the programs of different stations will get mixed up. In order to avoid this interference, it is necessary to translate or to shift this frequency range to different frequency bands. Okay, so in order to shift the frequency range to different frequency bands, we need a modulation technique. So in order to remove or reduce the interference, we need a modulation technique for the message signal. And also it overcomes the problem of poor radiation efficiency at low frequency. So this is the second parameter. And the third parameter is the reduction of noise. Now how the noise is reduced if you use the modulation technique? So we know that the noise is the major limitation of any communication system. Although we cannot completely eliminate the noise, but we can reduce the effect of noise on our signal that is transmitted through wireless channel. So in order to obtain the reduced effect of message signal, several modulation schemes are used, which will improve the quality of reception. So these are the major 3 parameters that is required or that is needed the use of modulation in the communication system.